Hey there, class. Welcome back to our lesson. Today we're going to be going over lesson 3, which is translations of exponential functions. This is really similar to what we just finished with conferences. So if you're still struggling with this idea of how to do a translation, this is a great lesson to watch because we're now going to be applying them specifically to exponential functions, right? So remember that in our last unit, we talked about the translations of a function and how they can be graphed. They can be graphed using this function. This is the general statement, right? Where you have an a value, a k value, a d value, and a c value, where a, k, d, and c represent the transformations that are being applied to this graph, right? In the case of an exponential function, this is how we would write what it would look like. The a value here would represent the vertical stretch or compression, right? The as well as the reflection, right? So if it's negative, it's reflected in the x-axis. Here we have, oops, this should also have a k there. And so in yours, it will have a k, right? X minus d. So I'm just going to go ahead and write that in a nicer little way. So I'm just going to k x minus d, right? So here, this k value represents the horizontal compression or stretch, as well as the reflection in x in the y-axis. Okay. And then our d value here, this represents the horizontal shift, so whether or not it moves left or right. And then lastly, our last value right here in green, that represents the vertical shift. So this is something a lot of people got confused on their conference. Just remember that C actually represents the vertical shift. It's always the last one, and that's up or down. Okay. And so here I just basically took the summary chart that we had from our functions before, and I went ahead and I made a better summary chart for us. So it's going to say if A is greater than 1, I'm sorry, just ignore the background noise. But if A is greater than 1, it is vertically stretched by a compression of A, right? If A is in between 0 and 1, it's vertically compressed by a factor of A, right? So if this is a function, or sorry, if A is like a fraction or a decimal, right? If it's greater than 1, it's going to be stretched. If A is less than 0, so it's a negative value, it's going to be reflected in the x-axis. If K is greater than 1, it's going to be horizontally compressed. So in this situation, it's just the opposite by a factor of 1 over K. If it's a fraction, it's actually going to be stretched by a factor of 1 over K. And if a K is 0, it is less than 0, it's going to be reflected in the y-axis. And then if you have b of x plus c, that means that it's going to move up or down, right? And if it's a plus c, it's going to move up. If it's a minus c, it's going to move down. If you have a of b to the power of x minus d, right? When you pull it out, so it means when you switch the value, if it's greater than 0, it's going to move right. And if it's less than 0, it's going to move left. But you remember you have to change the sign than what it is here. So if it's a negative here, it's actually a positive. If it's positive here, it's actually negative. Okay. So there's two ways that you can graph. The first one is using the order of operations. So you can go ahead and graph the base function y equals b to the power of x. This b is often going to be a number, so it's going to be 2, 3, whatever it might be, right? Then you're going to have to graph the a, b, x. So you're going to go ahead and multiply all of the y values by a. Then you're going to go and multiply all the x values by k, 1 over k, sorry. 1 over k, right? So you always have to flip it, and then you're going to go add, subtract the d and the c values, okay? So that's one way to do it. I personally like to use mapping rules because I like to do it all in one go, right? So I'm going to transform any key points of the base exponential functions into the image points of the final function using the mapping rule, right? The one thing here is you need to be careful to use the right base functions and the right base points. So here, y equals 2 to the power of x is not the same thing as y equals 4 to the power of x, right? They're two different functions. So you have to be sure to make sure you graph the right ones. So you can still use the same x values, just be careful with your y values, they're going to change. You can always find the base function by looking at what number the power is going to. So in this situation, our base function is going to be y equals 2 to the power of x. The best way to do this is honestly just to show you an example. But remember that this is what your mapping rule is. You're going to take your x values, divide it by k plus d, take your a value, multiply it by y plus c. So the first thing I'm going to do here is I'm going to go define my a, k, c, and d values. So a, k, c, and d. I notice that there is no a value, so I leave it as 1. There is no k value, so I also leave that as 1. The c here is actually the negative 3 at the end, and the d here is the positive 4, but when I pull it out, it becomes negative 4. Just by looking at this A, K, C, and D values, I know that my graph is not going to have any vertical stretch or compression. I know it's not going to have any horizontal stretch or compression because there's no values for that. And then I know that it's going to shift down by 3 because that's what the C value represents, and it's going to move to the left by 4. So I could honestly just go in, graph my function. So I'm going to go ahead and make my base function here. Oops. Just going to go ahead and graph that in there. So ignore the fact that it's not a very straight line, but get the idea. So I'm going to say x, y, and my y is equal to 2x. So I'm just going to pick some random numbers for my x here. So I always like to do -2, -1, 0, 1, 2. Right, so 2 to the power of -2 is going to give me 1 over 4 or 0.25. And the reason I write 0.25 is just easier to graph. -1 to the 2 to the power of -1 is going to give me 1 over 2, which is also just 0.5. 2 to the power of 0 is 1, 2 to the power of 1 is 2, and 2 to the power of 2 is 4. So now I have my base function. I'm just going to go ahead and plot that. I always like to put it in. So -2, 0.25. Right here, 1 goes up to 2, and 2 goes up to 4. And I just know that 2 to the power of 3 is going to be 8. Right, so I actually went ahead and did more than my table of values, but you don't have to do that. I just like that. So I can see that there's already an asymptote here at the 0, right? I just know that because I know that this is how this function works. So actually, I'm going to make a better graph. There you go. That's a better looking graph right there. Never mind, I thought it was. You get the idea. So like a curve going up, right? Now, one thing that I could do is I could just take each individual point. I know that it's going to shift to the left by 4 and down by 3. So I could actually just do that with each individual point. So I could go here, shift to the left by 4. So 1, 2, 3, 4, down by 1, 2, 3. Or I can go ahead and do my graphing rule. Whichever one works for you is how you should do it. Personally, for me, I personally like mapping rule. I like how clean the points are just using mapping rules. So that's how I'm going to do it. But it just depends on how you feel comfortable with that. So I know that my mapping rule is going to be x divided by k, which is just 1, plus -4, and then ay plus c, so 1y plus -3, right? So that's going to be x minus 4, y minus 3. So what I'm going to do here is I'm going to go and do x minus 4, y minus 3. So I'm just going to go and pick my x value. So it's -2 minus 4 is going to give me -6. Then I have -1 minus 4. That's going to give me -5. And I'm just going to continue to do this. So -4, -2, 3, and -2. So on the other side, I'm going to do 0.25, which is what my original y value was here, minus 3, right? And that's going to give me -2.75. I'm going to do 0.5 again, which was my value right here. Minus 3 is going to give me -2.5. And then I'm going to have 1 minus 3, which is going to give me -2. And then I have 2 minus 3, which is -1. And then I'm going to have 4 minus 3, which is just 1. So I'm going to go ahead and take these new points and plot them. So I'm going to go to -6, right? And I know that my new point is going to be at negative 2.75. So I'm going to go down to negative 2.75. So like here-ish, right? And then I'm going to do negative 5. That's going to go down to negative 2.5. Then I'm going to do negative 4, and that's going to go down to negative 2, so about here. Then I'm going to do negative 3, that's going to go down to negative 1, which is right here, right? And then I'm going to do negative 2, which is going to go down to 1. So it's going to be like here, right? So my graph is going to look something like this. Okay, so that's what my graph's going to look like, just on both sides. Something really important to note here is that here the asymptote is 0, right? Just like the points in my graphs move down, my asymptote also moves down to negative 3, right? So my new asymptote is going to be asymptote is at x equals negative 3, right? The asymptote is the c value. And if I wanted to find my domain and range here, I could find that. My domain here, x doesn't really have any restrictions on it, so x is an element of all real numbers, right? The range does, however, have a restriction on it. The range has to be greater than negative 3, right? Because that's our asymptote and it's always growing in the other direction. So y is an element of all real numbers such that y is greater than negative 3. Not greater than or equal to, because it never actually touches the greater than, it actually never touches the 3, so it's always greater than negative 3 because we have that as an asymptote. Okay? And that is going to be our first function. So if you still are struggling with that, I would say go back, pause this, try and do it again by yourself, right? Make sure you really understand how to go from the parent function to the new function that we have, because we're going to start putting a little bit more translations into it, so it's going to become more complicated. Okay. So the next thing we're going to do here is, if you put pause, try this one by yourself, because if you actually understand this, then you know how to do translations of exponential functions, which is important, but you also know how to do the transformations from the lessons that we had done last unit. So this is a great time for you to go back and make sure you know those skills, right? So here, first things first, we need to go find the base function. So a lot of people think it's 2x. It's not. 2 is actually the a value here, right? This is the b value. So that's actually the base. So our base function here is actually y equals 3x. And that makes sense because see how this x is to the power of 3, right? So make sure you're always looking at that number that the x is coinciding with. So let's go ahead and graph out our base function, or like make a table of values for our base function. So we have, I'm just going to do negative 1, negative 2. This is kind of my go-to. These are my go-to points, right? So then I'm going to say 3 to the power of negative 2 is 1 over 9. I always like to write that as a decimal, just because when you go to graph, it's easier to have decimal numbers than it is to graph fractions. So I'm just going to say, okay, 1 over 9 is just going to be the same thing as saying 1 divided by 9, which is going to be like 0.11, right? Then I have negative 3 to the power of negative 1 is 1 over 3, which is just 0.33. These are all repeating decimals, right? And then I have 3 to the power of 0, again, 1, 3 to the power of 3, 3, 3 to the power of 2 is 9. I'm just going to go ahead, plot that in here. So I'm going to say, okay, I have, this is my parent function, right? So that one's kind of hard to do, but you know, you get the idea. The ones closer to the 0 are actually really difficult to deal with. But we can move on and go on to this one. 2 to the power of 9, right? So we're just gonna, I'm just gonna go ahead and draw this in. So like this, like that, right? going to grow exponentially in that direction. Again, here, our asymptote is going to be 0. So we can actually find out what our new asymptote is just by looking at this. There actually is no C value, so there's nothing here. So our asymptote's going to stay the same. There's going to be no vertical shift. Okay, so let's go ahead and find our A, K, C, and D values. So I know my A value here is -2. That means that I have a reflection in the y-axis, so it's going to open down instead of opening up. I'm going to have it stretched vertically by 2, which means it's going to be a little bit stretched out a little bit not wider but thinner. The K value here is 1. I don't actually have a K. I don't have a horizontal or a vertical stretch, so it stays a vertical shift. It just stays the same. But I do have a D value of +1 because I pull out the 1. So again, I personally like to use mapping rules. So my mapping rule is X divided by K plus D, A, Y plus C. So I have X divided by 1. So I'm just going to leave it. Plus 1, A is -2, Y, plus C is just 0, so I'm not going to do that because it's just going to stay the same. So I'm going to put my new X plus 1 value and my -2Y value. So I'm just going to go ahead and say, okay, -2 plus 1 is going to give me -1. -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And then 2 plus 1 is going to give me 3. Okay, on the flip side, we're just going to multiply all of our y values by -2. So -2 times 1 over 9 is going to give me -2 over 9, right? Which is, I'm just going to write it as a decimal again because it's easier for us to graph decimal. So 2 divided by 9 is going to be 0 at -0.22, right? Then I have -2 over 3, right? So -2 over 3 is the same thing as saying -0.66, right? Then I have -2 times 1, -2, and then I have -2 times 3, which is going to give me -6. And then the last one is -2 times 9, which is going to give me -18. Okay, so then I'm just going to go ahead and pull out that function in. So I'm going to go look and say, okay, at -1, it's at like -1, it's like right here, right? At 0, it's at -2, 3, so it's like here-ish, right? And then at 1, that is actually like here-ish, right, technically. At 1, it's going to be at -2. At 2, it's going to be at -6, right? And at 3, the function is at -18, so it's like all the way down here. So my graph is going to look something like this. Okay, I'm just going to fix that. Something like this. You will have better graphs than me because I'm drawing on my iPad, but that makes sense. Looks a little bit more stretched out than the last one, right? Because if I was a better artiste, this would look a little bit like less like that. It would look more like this, right? It's growing a little bit faster. It's already reflected on the x-axis. It has the same asymptote, right? And it's shifted over 1, okay? To the left 1. And you can usually tell the shifts by just looking at this point right here, right? So if this point is shifted, then that means that we have a horizontal shift. Okay. Alrighty. So that's that. I always like to go ahead and just mention what the domain and range here is too. So for this one, the domain is still domain is x is an element of all real numbers. There's really no restrictions on x here. The range here is going to be a little bit different. Y is an element of all real numbers such that you'll see that the y's can only grow in this direction, right? So that means that such that y is always going to be less than 0, right? Because it can't ever touch 0. 0 is the asymptote. So the new asymptote or the same asymptote is x equals 0, right? It'll never touch it, but it'll get very, very close. So y is less than 0, right? Because it's not going to be greater than 0. So again, I'm going to let you try this one on your own, right? So pause the video here. Please go through it by yourself. This is the hardest one that you're going to get. Try it by yourself. If you understand it, then you understand this concept, right? And that's really important. But if you don't understand it, then we do need to go through it some more. And we can do some practice questions. There are a bunch of practice questions here, right? Some of them are really good. I really like 9, 10, and 11, right? And actually number 2 and number 3, I think, help make you find what the function is going to be by telling you the transformations. We kind of already did that before, but this is a great way to make sure that you know what the transformations represent. So you know what your A, K, C, and D values represent. It's a really good question for an assessment or a test. Especially if you are doing this as a test or so assessment in class, it's a good multiple choice type question, right? So that's something that I would know how to do, okay? All right, so I hope you pause the video here. Again, pause it, like actually pause it, go try this by yourself and then come back. All right, so hopefully you paused and you listened to me. So what we're going to do is we're going to actually go ahead and try this last function. We have quite a bit going on here, but the first thing you always need to do is you need to remember to factor. So this is going to be negative 1 over 2 for 2x minus 1, close bracket, minus 3. Now what I'm going to do is I'm going to go find my A, K, C, and D values. Those are really important. So let's go ahead and do that. My A value here is going to be negative 1 over 2. My K value here is 2. My C value, let's do my D value because that's actually the order that it goes in. My D value is positive 1. I'm just taking out that negative and changing it to a positive. And my C value is negative 3. And then I'm going to go make my mapping rule. So I know that my base function here is 4 because the exponent is going on my 4. So my base function here is 4 of x. I actually went ahead and just found the points for you and I put them in for you. I would change that 1 over 16 into a number that's easier to graph. So you can write it as 1 over 16 is equal to 0.0625. 1 over 4 is just 0.25. Okay? Like I just like to do that for myself. Let's go figure out what our mapping rule is. So I always like to do it off to the side. So x divided by k plus d, ay plus c. That's what it always is. So let's figure out x divided by our k value, which was 2, plus our d value, which we said was 1, right? A was negative 1 over 2, y, and we said our c value was plus negative 3, right? And I can just actually change this straight to minus 3. That's going to be my mapping rule, so I'm just going to go write that in here. So I know that the function is going to be x divided by 2 plus 1, right? And I'm going to take negative 1 over 2, y minus 3, and that's going to be my new points and what they're going to be. So I'm going to take x, negative 2 divided by 2 plus 1. So that's going to be negative 2 divided by negative 2 is going to give me negative 1 plus 2 is going to give me 1, right? So I'm just going to actually write just the points in here to save myself the trouble, but you understand where it's coming from, right? So then I'm going to plug in y, so I'm going to have negative 1 over 2 times 1 over 16, right, minus 3, and I ended up doing this as a decimal because it just made it easier for me. So it's going to be negative 3.03125. Here I'm going to take the negative 1 divided by 2 plus 1, which is going to give me 1.5. And my y is going to be 1 over 4 divided by negative 1 half, which is going to give me negative 1 over 8 minus 3, which is going to give me negative 3.125, right? Then I have 0 divided by 2, which is 0 plus 2 is going to give me 2. Then I have negative 1 over 1 minus 3 is going to give me negative 3.5. So I did this for all my points. I'm just going to put them in because I think it's getting pretty repetitive how I did these. So this is all my points that I found. And then I'm just going to go ahead. I always like to graph my parent function because for me, I personally feel like it helps me see visually the reflections a little bit better. Um, 0, 1, 1 goes up to 4, 2 goes up to 16, so like right here. So I'm just going to go ahead and draw this in. Always remember there's an asymptote there going up pretty steep, and that's what it looks like. Okay, so that's my base function. Then I'm just going to go ahead and draw in my other one. So I know I'm going to have 1, x of 1 goes down to negative 3.03, so like here-ish, right? Then I have 1.5, so in between the 1 and 2, it's going to go down to negative 3.125, so like here-ish. The 2 is going to go down to 3.5, so like this one's rough. So this one, in this case, the scale, I would actually encourage you to make smaller, but that's okay, we already have this. Right there. 2 is like here. 3 is 3.5, right? And then we have negative, then we have 2.5 goes down to negative 5. So you'll see that first big jump here, right here, right? And then we have 3 that's going to go down to negative 11. So 3 down to negative 11. So my graph is going to look something like this. Okay, and again, my asymptote here was 0. Just like the graph, it's going to shift down by 3. So my new asymptote is x equals negative 3, which also means that my domain is going to stay the same because nothing's really changing with my x's. They're all real numbers, but my range changes. My range is going to be y is an element of all real numbers such that y is less than, right? Because look, the y's are only going in the lower direction, less than 3, or negative 3 rather. Okay. And it's less than, not equal to, because it never actually touches negative 3. Okay, and that's it. That's our function. All right. So if you have any questions, if you had any questions, the best way to go about this is always write them down as you go along. But for sure, if you have any questions, feel free to ask. Your homework is posted here. It's already been posted in Google Classroom. And that's it. Thank you.